Dear students, welcome back to the class. In the previous video, we have studied about some of the properties of the inverse trigonometric function, the three properties. Now, we will see the fourth one. It's like this: sine inverse of x plus cos inverse of x is equal to pi by 2. Tan inverse of x plus cot inverse of x is equal to pi by 2. Cosecant inverse of x plus secant inverse of x is equal to pi by 2. Before proceeding this property, we should know the sine inverse, sine theta we can write in terms of cos theta as sine theta is equal to cos of pi by 2 minus theta. We know sine theta is equal to cos of 90 minus theta, and 90 I can write it as pi by 2. So sine theta is equal to cos of pi by 2 minus theta. Similarly, for tan theta we can write in terms of cot theta as cot pi by 2 minus theta, and cosecant theta is equal to secant pi by 2 minus theta. Using this, we can solve this, okay, or we can prove this. Proof. First, take sine inverse of x as y. Sine inverse of x as y, which gives us x is equal to sine y, shifting the inverse function to the other side. And I can replace sine function in terms of cos function. Okay, cos of pi by 2 minus y. See, sine y in terms of cos is cos pi by 2 minus y. Using this, sine y is equal to cos of pi by 2 minus y. Now I can shift this cos function. It becomes cos inverse of x is equal to pi by 2 minus y, or cos inverse of x. If I shift y to the other side, plus y is equal to pi by 2. Now, from this equation, I can write y as sine inverse of x cos inverse of x plus sine inverse of x is equal to pi by 2. This is our required property, right? Sine inverse of x, or I can write it as sine inverse of x plus cos inverse of x is equal to pi by 2. Clear? Only using this condition we can derive sine inverse of x plus cos inverse of x is equal to pi by 2. Similarly, we can prove for this tan inverse of x. Take tan inverse of x as y. Similarly, x is equal to tan y. The same procedure. And x is equal to, in terms of cot, it is pi by 2 minus y. And if I shift cot function to the other side, it becomes cot inverse pi by 2 minus y. Cot inverse of x plus y is equal to pi by 2. If I shift minus y to the other side, and we know from this equation y is equal to tan inverse of x. Y is equal to tan inverse of x is equal to pi by 2, or I can tell tan inverse of x plus cot inverse of x is equal to pi by 2. Similarly, for this cosecant inverse of x plus secant inverse of x, I will take cosecant inverse of x as y, and therefore x is equal to cosecant y. I can replace cosecant into secant function. It becomes secant pi by 2 minus y is in this condition, or it's equal to secant inverse of x is equal to pi by 2 minus y, or secant inverse of x plus y is equal to pi by 2. From this equation, I can substitute y as cosecant inverse of x is equal to pi by 2, or cosecant inverse of x plus secant inverse of x is equal to pi by 2. So, we derived the fourth property. We proved the fourth property like this. The next property is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy, where xy is less than 1. The product of xy is less than 1. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy, where xy product is greater than minus 1. Okay? To prove this, to prove the first one, I will take first or second one. I will take tan inverse of x as theta, tan inverse of y as psi. From this, x is equal to tan theta and y is equal to tan psi. Okay, just shifting the other. Okay, this is I am considering. Now let me take theta plus psi, angle these two with the tan function. We already studied in the trigonometric function tan of x plus y is equal to tan x plus tan y divided by 1 minus tan x plus tan x into tan y. So that I am using this property, it becomes tan theta plus tan psi. In the place of x we have theta, in the place of y we have psi. So 1 minus tan theta into tan psi. Just applying the formula. Okay. After that, I will replay or I will transfer tan theta to the other side. It will give us tan inverse of tan theta plus tan psi divided by 1 minus tan theta into tan psi. Okay. Now just replace what is the value of theta. Theta is tan inverse of y. What is the value of psi? It's tan inverse of y. Right? I will replace tan inverse of x plus tan inverse of y. Theta as like this. In the right hand side, it's equal to, I am replacing tan theta as x, tan psi as y in everywhere. So it is x, this is y, tan psi divided by 1 minus tan theta is x into tan psi is y. This is why the fifth property came. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Similarly, we can prove for the second part of the fifth property. That is, take the same way, tan inverse of x as theta, tan inverse of y as psi. So x is equal to tan theta from this, y is equal to tan psi. Tan psi. Now take theta minus psi because we require tan inverse of x minus tan inverse of y. Take these two, apply tan function. From the formula, tan x minus y is equal to tan x minus tan y divided by 1 minus tan x tan y. I am applying here tan theta, in the place of x we have theta, minus tan psi, in the place of y we have psi, divided by 1 minus tan theta tan psi. Again, shift tan function to the other side, it becomes tan inverse. So tan theta minus tan psi divided by 1 minus tan theta tan psi. So just replace theta as tan inverse, psi as tan inverse of x, y is equal to tan inverse, and now I am replace tan theta as x, tan psi as y, x minus y divided by 1 minus 1 plus xy. This is our proof for the second part of the fifth property. Okay. Okay. The next property is like this, and the fifth property is most important property. You can get many problems in the final examination depending on the fifth property. Okay, the sixth property is like this. 2 tan inverse of x is equal to sin inverse of 2x by 1 plus x square. 2 tan inverse of x is equal to cos inverse of 1 minus x square by 1 plus x square. 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square. This is nothing but we can convert tan inverse function to the sin inverse function, cos inverse function, tan inverse function, or 2 tan inverse function to the other form. For that, we should know the function of trigonometric function property. Sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta. Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta minus 1 divided by 1 minus tan square theta. All these properties we already studied in our first PU classes. If you want the proof of this property, please go through the first PU class textbook. Using this, we can prove these things. Proof. Here, I am considering the right hand side first, and I will applying the value of x as tan theta. Then I am getting the LHS in the expression. So, I am taking sine inverse of 2x by 1 plus x square. Taking RHS of this expression. Then I am applying x is equal to tan theta, which implies theta is equal to tan inverse of x. Okay, x is equal to tan theta means theta is equal to tan inverse of x. Just write like this. Applying to this function, sine inverse of 2 into tan theta divided by 1 plus tan square theta. Okay, this is RHS. I am applying just x as tan theta. Now you can observe in the bracket, it is 2 tan theta divided by 1 plus tan square theta, which is same as the right hand side of this expression. So I can replace the entire expression as sine 2 theta. Right? The same expression I can replace it by sine 2 theta using this property of trigonometric function. And you can observe there are inverse functions are adjacent, right? Here sine inverse of sine theta. It will give us the identical function, right? So that it will return us just 2 theta. Or you can say it is cancelling, but actually it will give us the identical function. So it will return 2 theta again. Now look at theta. What is theta? Theta is tan inverse of x. Just replace it is tan inverse of x, which is nothing but the LHS of the expression. So 2 tan inverse of x we can write as sine inverse of 2x divided by 1 plus x square. Similarly, I can prove here, take cos inverse of 1 minus x square divided by 1 plus x square and replace x as tan theta, because inside the bracket if we replace x as tan theta, we are getting the RHS of this expression. So I can replace this as in terms of cos. So theta is equal to tan inverse of x. Just replace RHS cos inverse of 1 minus x square divided by 1 plus x square, replacing x as tan theta, 1 minus tan square theta divided by 1 plus tan square theta is equal to cos inverse of, so this expression is nothing but cos 2 theta. This will give the identical function, that means it will return 2 theta itself. So 2 into, from this I can write theta as tan inverse x is equal to RHS. Clear? So same method for this also. Tan theta, put x as tan theta. So theta is equal to tan inverse of x. Next, take RHS, tan inverse of 2x divided by 1 minus x square. So I replace tan inverse function or x as tan x, 2 into tan theta divided by 1 minus tan square theta. Using this formula, I can replace the expression inside the bracket as tan 2 theta. This will give the identical function of x of theta. So it is 2 theta. So 2 into theta is nothing but tan inverse of x, which is equal to the RHS. So this is a proof of this expression. Therefore, the property 6 tells I can write 2 tan inverse of x as sine inverse of 2x by 1 plus x square, or cos inverse of 1 minus x square divided by 1 plus x square, or tan inverse of 2x divided by 1 minus x square. All these properties are important to prove our problems, to prove our next problems. Okay? Please go through all the properties and proof of the properties. It can come in our final examinations. Okay. Next we will see some of the problems based on these properties. The first problem is, show that, first one, sine inverse of 2x root 1 minus x square is equal to 2 sine inverse of x, where x lie between minus 1 by root 2 and plus 1 by root 2. If x lie between 1 by root 2 and 1, then this same sine inverse of 2x into 1 minus x square is equal to 2 cos inverse of x. So I will solve the first one. Similarly, you can solve for the second one. Okay. Here we have sine inverse function. So by substituting x value as some other trigonometric function, suppose we are getting this sine function in this, then we are cancel sine inverse and sine function, or we are getting the identical function in here. Sine inverse of sine function is identical function. What we did in the previous properties. Similarly, I will substitute here x as sine theta. I substitute x as sine theta. So theta is equal to sine inverse of x. Why I am substituting x as sine theta? Because if I substitute here x as sine theta, it becomes 1 minus sine square theta. We know 1 minus sine square theta is equal to cos square theta. So I am getting inside the square root as cos square theta. Then square and square root get cancelled. It becomes cos theta. And if this is cos theta and x as sine theta, here 2 sine theta cos theta I am getting. So we have the formula 2 sine theta cos theta is nothing but sine 2 theta. So sine theta I am getting here, sine inverse of I am getting here. So it will become the identical function. It becomes 2 theta, and theta is sine inverse of x. That is 2 sine inverse of x that we are getting if I substitute x as sine theta. Let me prove this. So RHS sine inverse of 2 into putting x as sine theta square root of 1 minus sine square theta. Why am square root of 1 minus sine square theta is equal to cos theta? Because we know 1 sine square theta plus cos square theta is equal to 1. We know sine square theta plus cos square theta as 1, or cos square theta is equal to 1 minus sine square theta, or cos theta is equal to square root of 1 minus sine square theta. So you can replace entire this portion as cos theta, right? So this expression becomes sine inverse of 2 sine theta into cos theta. And 2 sine theta cos theta, we know sine 2 theta is equal to 2 sine theta cos theta. So same expression I am getting inside the bracket. So it is sine inverse of sine 2 theta. Okay, you can observe we are getting the composition function of two inverse functions. So it is identical function of 2 theta. It will return 2 theta itself. That is nothing but, if theta is sine inverse of function, this is 2 sine inverse of x, which is nothing but RHS. So sine inverse of 2x root 1 minus x square is equal to 2 sine inverse of x if x lies between minus 1 by root 2 and 1 by root 2. This is a proof of the first part of this portion. The second part, it is an exercise for you. So can you get the sine inverse of 2x by root 1 minus x square as 2 into cos inverse of x. In the next problem, second problem, we are going to use our fifth property. The problem is like this. Show that tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. And take the LHS left hand side, that is tan inverse of 1 by 2 plus tan inverse of 2 by 11. We can prove it's equal to tan inverse of 3 by 4. We know from the property phi, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Right? Tan inverse of x plus y divided by 1 minus xy. You can observe this looks like tan inverse of x plus tan inverse of y. Here x is 1 by 2, y is 2 by 11. So that I can directly write it's equal to tan inverse of x plus y. This is x, this is y. 1 by 2 plus 2 by 11 whole divided by 1 minus xy. So 1 by 2 into 2 by 11. Just taking the LCM here, this 22 11 plus 4 divided by here it is 22, 2 by, this become 2 by 22, so it is by 22. Taking the LCM, 22 gets cancelled, is equal to tan inverse of 15 by 20. If I divide this fraction by 5, it becomes 3 by 4. So this is nothing but the RHS of the problem. This is a way to prove this problem using the property phi part 1. Okay, clear? I will explain again. Here x is equal to 1 by 2, y is equal to 2 by 11. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus x square. I am applying that formula here. Tan inverse of 1 by 2 plus 2 by 11 minus divided by 1 minus 1 by 2 into 2 by 11. Taking the LCM, it becomes 22. In this 11, 1 into 11, so 11, 2 into 2, it's equal to 4. And here, this expression is 2 by 22. So 22 into 1 is 22 minus 2 divided by 22. 22 gets cancelled. It is 15 by 22. If I divide 15 by 22 by the number 5, it is equal to 3 by 4. That is the answer, tan inverse of 3 by 4, which is the RHS of the problem. The next problem is tan inverse of cos x divided by 1 minus sin x. We have to express this expression in the simple form. The simple form means we have to delete as much as possible the inverse function in that expression. Okay, inverse function illadage just now reduce model simple form. Okay, for that the main thing is here it is 1 minus sin x, and we know 1 minus sin square theta is equal to cos, or 1 minus 2 sin square theta is equal to cos 2 theta. Okay, or I can write 2 sin square theta is equal to 1 minus cos 2 theta. Here the denominator should become any one function. Okay, either it is cos function, we should convert this as cos function, the numerator in terms of sin function. Then only we are getting sin x divided by cos x. So tan x we are getting in this bracket, and tan inverse of tan x become the identity. So this tan inverse vanishes. To get this function as cos, okay, this we know 1 minus cos square theta is 2 sin square theta, right? So I want convert this function as cos function, and here in the numerator I require this sin function. So I replace cos x as sin pi by 2 minus x, and here sin x as cos pi by 2 minus x. So the expression is like this: tan inverse of cos x divided by 1 minus sin x. We can write it as tan inverse of sin pi by 2 minus x divided by 1 minus cos pi by 2 minus x. Just I will simplify the expression inside the bracket. It's equal sine. If I take the LCM, pi minus 2x by 2 divided by 1 minus cos pi minus 2x by 2. Now look at here, you are getting the expression like this, 1 minus cos 2 theta. Here in the place of 2 theta we have pi minus 2x by 2. Right? In the place of 2 theta we have pi minus 2x by 2. That means theta is equal to, I should divide the whole expression pi minus 2x by 2 whole divided by 2, that is pi minus 2x by 2 into 1 by 2 pi minus 2x by 4. Here, if 2 theta is equal to pi minus 2x by 2, theta is equal to pi minus 2x by 4. Therefore, 1 minus cos 2 theta we have pi minus 2x by 2. Right? 2 theta is pi minus 2x by 2. So, if I replace this as in terms of sine, that is, we should write theta value. Now we are getting 2 theta is pi minus 2x by 2, means theta as pi minus 2x by 4. So entire expression in the denominator, you can write it as 2 into sine square of pi minus 2x by 4. I will write here it's equal to 2 into sine square pi minus 2x by 4. ಅದಲ್ಲ ಇಲ್ಲಿ pi minus 2x by 4 ಯಾಕಂತ ಹೇಳಿದ್ರೆ cos in the formula we have 1 minus 2 sin square x is cos 2 theta or 2 sin square theta is cos 2 theta. ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನೋಡಿ 1 minus cos 2 theta ಅಂದ್ರೆ ಇದು 2 theta ಆಗಿರ್ತದೆ. 2 theta ಆದರೆ theta is pi minus 2x by 2 whole divided by 2 or pi minus 2x by 4. In the left hand side ಏನಾಗ್ತದೆ 2 into sin square pi minus 2x by 4. What is the numerator? Numerator we should get cos in terms of cos or sine, right? Here we have sine square, right? To get this tan inverse or cot inverse easily tan inverse convert ಮಾಡಬಹುದು. But to get the cot or tan, we should get one sine. It's enough. We should get one sine, not sine square. So that I'll replace this sine of pi minus 2x by 2 using the formula sine 2 theta is equal to 2 sine theta cos theta. Just observe here, I will compare sine 2 theta with this sine pi minus 2x by 2. Now you can see 2 theta as pi minus 2x by 2. So theta is pi minus 2x divided by 2 into 2. Theta is equal to pi minus 2x by 4. So that in the right hand side it becomes 2 into sine pi minus 2x by 4 into cos pi minus 2x by 4. Clear? So that I can write sine pi minus 2x by 2 as 2 sine pi minus 2x by 4 into cos pi minus 2x by 4. Just observe it, why I am writing like this, sine pi minus 2x by 4 cos pi minus 2x by 4. Can you guess why I am splitting this as this? Yes, your guess is right. Here in the numerator expression 1 sin pi minus 2x by 4 will cancel with the denominator of 1 sin pi minus 2x by 4. Then this expression becomes tan inverse of, and here also 2 gets cancelled. This becomes cos pi minus 2x by 4 divided by sin pi minus 2x by 4. Here. So now you can think of it. Here the element in the cos function and in the sine function are same. If the element of the cos function and sin function are same, then you can write it as cot function. So cos x by sin x, it is equal to cot x. So this become cos pi minus 2x by 4 divided by sin pi minus 2x by 4 become cot pi minus 2x by 4. So I can write this as tan inverse of cot, split this, pi by 4 minus 2x by 4, or tan inverse of cot of pi by 4 minus x by 2. Now it is simple to convert cot function to the sin function. We already know tan theta is equal to cot of pi minus 2 theta, right? We already know cot theta is equal to tan of pi by 2 minus theta, right? So I am using this expression here, which is tan inverse of cot theta. I replace in terms of tan. If it is theta, pi by 2 minus theta is pi by 4 minus x by 2. Just apply this formula. So tan inverse of tan becomes the identical function. It will give the elements inside the bracket, that is pi by 2 minus pi by 4 minus x by 2, or pi by 2 minus of pi by 4 minus of minus, it becomes plus x by 2. Pi by 2 minus pi by 4, taking the LCM, it is 4. 2 pi minus pi plus x by 2 is equal to pi by 4 plus x by 2. Here you can observe there is no trigonometric function or inverse trigonometric function. This is the simplest form of the tan inverse of cos x divided by 1 minus x square. So this kind of problem requires lot of practice to crack the solution. Okay, crack these problems. So similar kind of the problem which is there in your exercise, please go through this, go through all of them and try to get the answer. Okay, it's enough today. So with these problems we have ended the second chapter, inverse trigonometric function. The next problem, in the next videos we will see the next chapter, that is matrix.